So more like this one. Y equals arc sine of maybe x plus 2. Or maybe more likely plus pi. Make it better. But should be a simple one. Maybe y equals 2 sine of 6x. Or maybe y equals tangent of x over 2 minus pi 4. Stuff like that. It's relatively simple. Yeah. 6x. Yeah.
Do we solve the equation for x and then plug in the y? That's how
You can.
Is that just hard to say?
I mean, it's your choice how to do it. That way it will work. I mean, I prefer just look at what number can I use arc sine of. Every number from negative 1 to 1. Let's see. Something along those lines. I don't know exactly. I just think of it more of where is tangent undefined at? Pi half, 3 pi half. So what would I have to plug in for x for me to get pi half as my answer? So I would do x over 2 minus pi 4 equals pi half. And solve that. Because that will tell me where one of my undefined points are. And you can use a period to say where the next one's going to be. So x over 2 equals 3 pi over 4. So x equals 3 pi half. So then what's the period? Yeah, 2 pi. So it's pi divided by 1 half. So period is 2 pi. So I've got my first one is 3 pi half, and then I go up 2 pi or down 2 pi and get other of the asymptotes. Once you get asymptotes, it's fairly simple. And I would suggest if you're labeling it, put 4 boxes between your asymptotes. So you've got your middle and you've got your 1.
How many asymptotes are there to period?
For tangent and cotangent, it is 1 asymptote every period. For secant and cosecant, there are 2 every period.
Are we going to have to graph?
Sure, why not? So I can add that to the list, maybe y equals secant of x plus 1. So the first thing I would do with any of the ones that you know have asymptotes is find where those asymptotes are. So for example, where is secant have its asymptotes?
Negative pi over 2.
Okay, negative pi over 2 or pi over 2. So we would be able to do it. Negative pi over 2, right there, pi over 2, and then every pi unit from there. And remember what secant does. It has 1 up top, 1 at the bottom, 1 at the top, 1 at the bottom. And notice this is shifted what direction? Up 1. That's just not in here. So this is up 1. So my center line is going to be at 1. And it's fairly, I mean, everybody see how you can get from there? Build it, plug in maybe the middle point between them.
So what's the period?
Here's 2 pi over b. So what is b?
1.
1. So 2 pi. So this was negative pi half here. This is pi half. How far are they apart? Pi. And so this would be 3 pi over 2. Or no, pi. This would be pi. Right? If I was looking at it by pi half, and this would be 3 pi over 2. So I sort of put these a bit further apart than I needed to. But yeah, you'd have like something here, and then something down here, something up here.
So the period is 2 pi, there's like 3
That's an asymptote every pi. So from here to actually this should be 3 pi half, this is an asymptote. You're right. 3 pi over 2. I do an asymptote. But yes, from here to here is pi, right? How far from pi half? 3 pi half. 5, so that's another asymptote. And then 5 pi half, so you get another asymptote. So I was right about that, it's just I had the wrong label. Yeah, so it's a tangent with this as with period being 2 pi. Yeah. So should be able to do some graphs by hand. You can just plug in some points, which also brings us to the unit circle. You need to know that still. So there'll be questions, like there'll probably be a set of 10 questions, maybe 20 or 30. That you should be able to do fairly quickly. So I also believe on the test I'm going to have the unit circle there. You don't have to fill it out, but you can choose to fill it out so you can help to answer the question. But maybe I'll have 10, 15 questions that are just like sine 3 pi over 4. Secant of, say, 720 degrees. Stuff like that. One. And maybe some other ones like that I'm not looking for exact answer. Like, hey, how about this? If I gave you or told you sine of 20 degrees, not the values, but is it positive, negative, or 0? Or undefined?
Positive.
Yeah, sure. Okay. How about the cosine of 375 degrees? Okay, where's 375 degrees? Yeah, it's still over here, 15 degrees. There's more than once around. And x is positive, so cosine is positive. How about the tangent of, say, 7 pi over 5? Okay, why? Okay. How do you know it's in the third quadrant?
Because it's greater than I, but it's not
Okay, so it's greater than pi, because pi would be 5 pi over 5. But less than 3 pi halves, because that would be 7.5 pi over 5. Because 7.5 over 5 is 3 halves. So it's between those two, therefore it's in the third quadrant. Tangent is y over x. Both y and x are negative in the third quadrant, so it is positive. Does that make sense how that can be done? So even if you don't know what it equals, you can tell me whether it's positive, negative, or 0 undefined. And let's see, what else do I have in calculator? Maybe simple SOHCAHTOA type question.
Non-calculated?
Yeah. So by simple I mean, say if I gave you this triangle, 3, 4, tell me what the sine of theta equals. What is the tangent of theta? Stuff like that. You should be able to do that with that calculator, right? Calculator section. Maybe a bit more complicated. Since most of these should be relatively simple, some of it's just straight up memorization. Sketch an angle, like in standard position. So if I told you, sketch for me a 390 degree angle in standard position. Yeah, so what does it mean to do that?
Isn't that just being a 30-degree angle with one circle?
Okay, so a 30 degree angle, because it's 30 degrees more, but because it's 390, we're going all the way around as one.
Oh, you just,
Or maybe I say a negative 5 pi over 7. Sketch for me approximately a negative 5 pi 7th angle. Okay, somewhere around here. How do we know that? Okay, because it's less than pi, more than pi half, and it's negative, so it's going downward.
So, what is it? What is the no? What is the
Oh, it would be somewhere towards the middle of it. It's somewhere towards the middle between pi half and pi. And also maybe converting, so how it sketch an angle or convert from radian or to degrees. So how would you change this to radian, 390 degrees? So you give me a formula memorized in case you forgot, or at least have a way to figure it out. You know how to set up the ratio. Okay, so degrees over 180 equals radian over pi. And just remember the ratio of your angle to half the circle is the same as your angle to half the circle. And simplify it. How do you simplify that? Or solve for radian? So you can cancel zeros, so 3 goes to 39, so 13 over 6, 13 pi over 6. Yeah?
Did you want boyfriend,
Degrees radian?
rating?
Yeah. So 5 pi 7. I have that right there. 5 pi 7. So degrees over 180 equals 5 pi over 7 over pi. The more fun ones are when I don't include pi in the pi. Maybe. But in that case, I'd be looking for a decimal answer problem instead of an exact. So if I have this one, similar to the way like I cancel 0, I'm going to cancel pi. So we got pi on top and pi on the bottom. So you get degrees over 180 equals 5, 7.
Well, like, what if you like actually did 5 pi over 7 over 5, you have to multiply 5 pi and 5
I'm not sure I follow it. So if you're dividing by pi here, okay, so what's the reciprocal of pi? So I'd be multiplying this times 1 over pi, and pi cancels. So either way, it's just recognizing that you can do it there. To finish this one, what's 5/7 times 180? So 5 times 180 is 500 plus 900. The degrees is 900 over 7. And there's no way it's going to simplify to 7 decimals 900. Let's see. Also, solving triangle. Definitely some solving triangles problem. Now this could be, what are the three methods we have for solving triangle? The log sine, log cosine, and SOHCAHTOA. So you should have your log sine memorized and log cosine. Or we have to generate them if we can't memorize. All the generate them is a bit more challenging. So when you're solving a triangle, what does that mean? Yeah, make sure when you get to the end, you should have all the lengths, all the angles. So if I gave you a triangle, let's say 5 degrees, 8 degrees, 6. What are the pieces you need to find? If you touch an angle. Is there more than one solution to this? How do you know? Let's do it on the triangle, how about? And if you have two angles. It's AAFK. Right? AAFK.
What do you mean by more than one? Like, is that you can?
Yeah. With the SSA case. So if I told you A equals 6, B equals, what is it? Okay, yeah, 8, something like that, you might generate more than one solution. No.
No.
What is the Pythagorean theorem require? A triangle. And let's say, whatever, 40 degrees, something like that. You might generate more than one case. In which case, you can solve for both cases. Yeah. Okay. What? So first we have to check, is there actually two cases? Okay. H equals B sine A. What is B sine of A? What? So 6 sine of 40?
8 times 40.
So 8 sine of 40. What do you get? 5.14. So it is less than A and B is greater than A, so there are two cases in this. Yep. So first thing I would do is solve for one of them. How? Sine 40 degrees over 6 equals sine B over 8. Solve for B. The inverse sine of 8 sine 40 over 6. So 58.99 degrees. So make sure you're in degree radian mode, whichever is appropriate on the cap test. So if that's B1, how do you get B2? Yeah. So take 180 minus 58.99. So now I've got B1, B2. So now we can get capital C1 and capital C2. And that's just taking 180 minus 40 minus 58. So it could be like 81.01 degrees. And then 180 minus this, minus 40, 18.99 degrees. And then you get C1 and C2, little c1 and little c2, using law of size again. That's how you get your two cases. Most likely, if I decide I want to put one of two cases, I'm going to tell you this has two cases in the instructions.
Is it like this, or are you doing?
I don't know, that's one of the problems I'm debating. I have it on there right now, or I have one on there right now that has it. However, I'm debating whether I want to do it or not. So another thing, more complex graphs. So I might ask you to make a graph that's a bit more complex, right? I don't know, y equals 1/3 x sine of x. What can you tell me about this graph? What's it going to do? Yeah, exactly. And if you remember doing the homework, if you drew the damping factors, the two 1/3 x and negative 1/3 x, the graph is constrained between them. Like if you drew the graph, it would look something like this. I think I was like.
We didn't have to like draw it back.
Then, maybe simplify an expression. What do I mean by that? So the maybe cotangent of the inverse or inverse cosine of 1 over x. Let's see. That's the last thing I have on my list here. You follow how you can do that? Yes? Yeah. The easiest way, I think, is draw a triangle. Label your angle that you're dealing with. So how do you set up this thing? 1 over x for cosine. Okay, and how do you figure out third side? I don't know. Okay, 1. Okay, fine. That's when you pointed up there, it's like you're up there. Okay, so how do you get third side? So, square root of x squared minus 1. And then what's the cotangent of that angle then? Yep. So, any other questions? What? I would probably would. Yeah. Oh, it depends. You generally don't want irrational numbers on the bottom, right? However, there's no guarantee that it's irrational. Actually, I would take it either way. So this is an interesting thing when you start looking at like calculus and stuff. Sometimes you leave it like that, sometimes it's not, and generally it's not marked off for leaving it in this form because it just gets much more complex when you start trying to rationalize the denominator.
If you like that on level.
That'd be fine, either way. But it's just, the goal is making it right in the simplest form that we can. Well, it would be square root of x squared minus 1 over the square, or over x squared minus 1. You still have to have the square root on top. So, questions about what's stuck on the test? Yeah, Kelly.
Can you grab y and start playing x code that?
Okay, let's see. So y equals arc sine x plus pi. Okay, so tell me about it. Okay, move that pi, good. Now, if we ignore that for now, so if we ignore this, so we're going to keep it there, but we're going to ignore it. What would the graph look like? Or what is the graph constraint between? Like, what values can I plug in for x? Everything's negative 1 to 1. Because that's the maximum sign. So let's say 1, 2, 3. Then we call this one 1, 2, 3, 4, and that one's negative 1.
Why is y negative 1?
Okay, what's the highest sign to go? You go to a circle. Remember, just looking at the circle, if we drew the circle in here, for example, how high on the y-axis does it even go? The highest y value is 1. The lowest y value is negative 1. So when you're looking at the sign, it is constrained between negative 1 and 1. And normally we go from negative pi half to pi half. So let's plug in a number. If we plug in negative 1, what is the arc sine of negative 1? But we want sine is between what two values? Negative pi half and pi half. So arc sine of negative 1, we're going to have It is 3 pi half, but what would be the one we want? Negative pi half. So arc sine of negative 1 would be negative pi half. However, it's shifted up pi units. What's negative pi half plus pi half? Or plus pi, I mean, up. So I know that this point right here is here. If I did 1, what's the arc sine of 1? Pi half. Pi half plus pi is 3 pi half. So I plugged in 1. Arc sine of 1 is pi half plus the pi here. I'm not sure I'm following. Oh, so this pi adds to that.
Oh, okay.
Remember, we're moving up pi from whatever value we get. So if we plug in 0, what's the arc sine of 0? 0 plus pi. Pi. So we know we've got those 3 points. What happens in the middle? So this is negative 1/2 and positive 1/2. What is the arc sine of negative 1/2? What? What happened? So where is y equal to negative 1/2? Oh, it is quadrant 3, but also quadrant 4. So what is the one in quadrant 4? Negative 1/2, right there. It's on 5 or 6, but what would be the one within our range, or domain we want? Negative pi 6. So, negative pi 6 plus pi would be? So at negative 1/2 we're at 5 pi over 6, where would this be? Probably in this neighborhood, and we know we're going to have the mirrored one over here. I sort of compressed this a little bit more than I wanted to, but oh well. So I started doing this, the whole sine graph by being a really confusing thing. And if we wanted, we could plug in some more points. Like, if we get root 2 over 2. What is the inverse sine of root 2 over 2? Pi 4. So pi 4 plus pi would be? Yeah, pi 4. So that would be here. And now where is root 2 over 2? 0.7, so it would be about right here, so it should be, actually it should be up here more.
Do we have to have, like, root 2 over 2 memorized, like, what it actually
What part of it? Which part of it? As long as you can get the good part, or the key part of the graph, you don't really need that one. So root 2. There you go. None of us needed that.